These notes are on page 3 of your spiral. You can draw out the boxes, or you can just write the definitions if you want. We're doing a review on the real number system. The real number system has an abbreviation or a symbol right up here. It looks like an R with an extra tail on it. So we're just going to talk about real number system. We have reviewed imaginary numbers in the past, but we're only going to be focusing on the real numbers. And we're going to start down with natural numbers, all the way at the bottom. So this is a subset of the real number system. Natural numbers have a symbol of n, and they are the whole numbers, the counting numbers, not including 0. So 1, 2, 3, 9, 82, 703. There are no decimals, no fractions. These are numbers that you count with. The next subset we have are whole numbers. Whole numbers have an abbreviation of W. They are all the natural numbers, but they include 0. The next subset are integers. Integers have a symbol of Z, and integers include all the natural numbers, all the whole numbers, and the negative numbers. There are no decimals. So you'll see -1, -4, -7, -182. They also include 0, 37, 400, and 1, 2, 3, 9, 82, and 703. Expanding up, we have rational numbers. Rational numbers have a symbol of Q, and rational numbers include terminating decimals, which are decimals that end, so like 5/10, which is 1/2. 2/3 is 0.6 repeating, so repeating decimals are also part of rational numbers. 4 2/10, -91, and then we had a lot of fun with 1/7. We actually did the long division, find out that it has a very long repeating component to it. So rational numbers are numbers that can be turned into fractions where the denominator is not 0. And then lastly, we're moving up to irrational numbers. They are not Q. That symbol here, that squiggle, that means not. Not Q, they're not rational. So pi is an irrational number. The square root of 2 is an irrational number. These are numbers that go on forever, and they do not repeat. So what we did in class when you were out was we did some practice on page 2. We did page 9, number 15, A through C, and then 16, 17, 18, 19, 20, and 21, starting with 2 and 5/10. And these problems are on page 10, and it's to identify which subset of the real number system that they're in. And you can just write the symbols if you want. I will post the answers to these at the end of the video. Yesterday we had a little bit of a math debate. We had the problem, which is right here, and it's 2 multiplied by the sum of x plus 4 divided by 3 minus 8 equals 32. So we had, just going with your gut, do you think that adding 8 to both sides would be the best first step? Or do you think that multiplying both sides by 3 is the best first step? So what we did in class is we took a minute and we just highlighted the one that we thought would make more sense to us, and then we split into 2 groups and we worked it out, and we talked about both steps and why they both work and which one might be easier to do than the other. So the first thing we're going to do is add 8 to both sides. So if we added 8 to both sides, remembering we are undoing the operation and following reverse order of operations. So adding 8 to both sides would leave us with 2 parentheses, x plus 4 divided by 3 equals 40. And then the next best step will be to multiply both sides by 3. So over here you have 120, and when you multiply by 3, because this is the denominator, these will cancel each other out. So you're just simply left with 2 parentheses x plus 4. Now when we got down to here, some students wanted to distribute, which you can. Because this is an even number, 120, it's actually going to be a little bit easier if you just go ahead and divide by 2. And you get x plus 4 is 60. And then if you subtract 4, you get x equals 56. So let me go ahead and get to the next screen. I'm going to distribute the 2 to the x plus 4 and just show you that you're still going to get the same answer, okay? It's just a matter of preference. 2x plus 4 equals 120. If you distributed, you would have 2x plus 8 is 120. You would subtract 8 from both sides. You'd have 112. You're still going to get 8 is 56. So it all depends on what you're comfortable with. If this number here wasn't even, you're not going to want to divide by 2 because, I don't know, I might just not want to deal with fractions. If this number, if you recognize that you can divide these two numbers evenly, whether this is a 3, because 3 would go into 120 evenly, you can go ahead and do that. But also distributing works. So let's go ahead and take a look at what multiplying both sides by 3 would look like. So this is where it gets a little tricky. When you multiply both sides by 3, everything has to get multiplied by 3, including the minus 8. So now the only thing that's clearing out is the 3, but we have to multiply this by 3. And this is where one of the groups made a mistake. It's minus 24. They forgot to multiply this by 3. If you add 24 to both sides, you're back to the 120. So I personally, for a problem that has something hanging off the end or in the front, I would get rid of that first, and then I would divide by 3. Or multiply by 3. If the problem just was this, I would definitely multiply by 3. Obviously, it's going to be the easiest thing to do. But just be careful when you have a problem like that. Let's do a practice one. I'm going to go back and do this basic one first. Go ahead and try and solve this. I'm going to keep working, but pause the video. You're going to subtract 14 from both sides. And then these cancel out. Divide by 4. Get x is 2. This is the second practice problem. Pause the video while you work on this. We're going to add 3 to both sides. Divide by negative 6, and x equals negative 7. Be careful, that negative tripped up some people. And now we're back to the problem that was similar to the one we started with. So I am going to subtract 4 here and get rid of this. 3x minus 1 divided by 2 is 5. I'm going to multiply both sides by 2. That simplifies out. 3x minus 1 is 10. Add 1 to both sides. 3x is 11. Divide by 3. And leave it as a fraction. Okay. Now the last page is going to have the answers from the classwork we did on the real number system.